Blockchain explained what it is and why it actually matters. For a while, I just avoided the word. My friend got me into Bitcoin. I started doing research. I was learning about mining, about wallets, about how transactions work. And the word blockchain kept coming up everywhere. And every time it did, I'd kind of skim past it because it felt like one of those words that sounds technical but doesn't actually explain anything, like synergy or the algorithm. People say it and nod like something got communicated. Nothing got communicated. But at some point my friend asked me directly, "Okay, so do you actually know what a blockchain is?" And I realized I didn't have an answer, not a real one. I'd been learning about Bitcoin for months, and I'd been treating the thing it runs on like a detail I didn't need to understand. That's a problem. So I went and figured it out. And what I found is that it's actually not complicated at all, once you understand what problem it was designed to solve. That's what this video is. No buzzwords, just the actual thing. Here's why this matters, even if you're not a crypto person. The word blockchain is everywhere. It shows up in news about Bitcoin. It shows up in news about NFTs, supply chains, voting systems, healthcare records. It's used to sell things that have nothing to do with each other, which means if you don't understand what it actually is, you can't evaluate any of those claims. You can't tell if a project using a blockchain actually needs one. You can't tell when it's a genuine innovation and when it's just the word stuck on the front of something for marketing purposes. There's a lot of the second one, by the way. So, what is a blockchain actually? Let's build it from scratch, starting with the problem it was designed to fix. Start with a simple problem. You want to send someone money. How does that work? Right now, there's always a middleman, a bank, PayPal, Venmo, Stripe, whatever. And that middleman does one thing. It keeps a record, a list of who owns what. When you send money, the middleman updates the list on both ends. The reason we need a middleman is trust. You don't trust me to just say I paid you. I could be lying. I could have already spent that money. The middleman is the authority that both of us agree to believe. That works, but it has costs. The middleman charges fees. It has rules about who gets access. It can be hacked. It can go bankrupt. It can freeze your account. It can make decisions about your money that you didn't agree to. You are ultimately dependent on that institution to keep honest records. The question that started Bitcoin and the blockchain was, what if you could have a trustworthy record without a single middleman in charge of it? Here's one way you could try to solve that. Instead of one institution keeping the record, what if thousands of people all kept the same record simultaneously? Every transaction gets broadcast to the whole network. Every computer on the network updates its copy. If your copy says you have $10 and you try to spend 20, every other computer on the network will immediately reject that. The record is checked by everyone at once. This is called a distributed ledger, and it's the foundation of what a blockchain is. But there's a problem with a shared ledger. Who gets to add new entries? And how do you stop someone from adding fake ones? This is where the chain part comes in. Transactions aren't recorded one at a time. They're batched together into groups called blocks. About every 10 minutes in Bitcoin, a new batch of transactions gets collected, verified, and recorded as a single block. Now here's the clever part. Each new block contains a reference to the block before it. Specifically, it includes a fingerprint of the previous block's data, a unique code generated by a mathematical function. That fingerprint is called a hash. It works in one direction only. You can instantly generate a hash from any data, but you cannot work backwards from the hash to recover the original data. Even changing a single character in the input produces a completely different hash, which is what makes tampering detectable. What this means practically, if you tried to go back and change an old transaction, say to make it look like you paid less than you did, the fingerprint of that block would change, which means the next block's reference would be wrong, which means every block after that would be wrong. You'd have to redo all of them. That's why it's called a blockchain. Each block is chained to the one before it. The history is not just a list, it's locked together. Changing the past breaks the chain. So the record is distributed. Thousands of computers keep a copy, and the record is chained. You can't quietly change the past, but there's still one more problem. What stops someone from rewriting the history and broadcasting their fake version to the network? This is what proof of work solves. To add a new block, miners compete in a brute force guessing race. Their computers try billions of random combinations per second until one of them produces the right answer. It's less like solving a clever equation and more like rolling dice until you hit a jackpot, except you're rolling billions of times per second. The winner gets to add the next block and gets paid in Bitcoin for doing so. To rewrite history, you'd need to redo every block from the one you changed to the present, while the rest of the network is still adding new ones faster than everyone else combined. At Bitcoin's scale, that would require billions of dollars in specialized hardware and electricity, and you'd have to outcompete every miner in the world simultaneously. Estimates put the cost of sustaining such an attack at millions of dollars per hour, possible in theory, economically irrational in practice. That's the security model. Not a bank vault, math and consensus. Okay, so now you know what a blockchain is. The real question is, what is it good for? The honest answer is two things very well, and a lot of things less clearly. The first use case, the one blockchain was built for, is digital money that nobody controls. Every other form of money you use has an issuer. The dollar has the Federal Reserve, the pound has the Bank of England, Visa dollars have Visa, PayPal dollars have PayPal. Even the money in your bank account isn't really yours. It's a liability on your bank's balance sheet, meaning you have a legal claim on that money, but the bank is actually holding and using it. If the bank fails, you're a creditor. Bitcoin is the first digital asset that has no issuer. No one created a company that owns it. No one controls the supply. No one can change the rules unilaterally. The blockchain is why that's possible. It lets millions of people agree on the same record without any of them being in charge. For that specific use case, scarce digital money with no central authority, the blockchain isn't just useful, it's the only way to do it. The second major use case is smart contracts. This is mainly Ethereum's territory, and we'll do a full video on it, but the short version is this. A smart contract is code that lives on the blockchain. It executes automatically when certain conditions are met. No lawyer needed, no bank to enforce it, no company to run it. The code runs itself, and the blockchain makes sure it runs exactly as written. That has real applications. Decentralized finance, lending, borrowing, trading, without a bank in the middle. NFTs, digital ownership, records that can't be faked. Certain types of insurance, where a payout triggers automatically when a verifiable event occurs. Whether those applications end up being worth the complexity is a genuine debate, but the capability is real. Here's where I want to be honest with you because this matters. A lot of things that claim to use blockchain don't actually need one. The question to ask is, does this system need to function without a trusted middleman? If the answer is no, if there's already a company or institution that all the users trust, then a regular database does the same job cheaper and faster. A blockchain database is slower than a traditional database. It requires enormous computing power. It's more complex to build on. The only reason to use one is if you genuinely need the properties that make it different. No central control, no single point of failure, an immutable record that nobody owns. A supply chain company tracking its own boxes on its own blockchain that it controls? That's not a blockchain. That's a database with extra steps. A bank running a blockchain-based payment system where they're the only validator? Same thing. When you see the word blockchain attached to something, the question to ask is, who controls the validators? If the answer is one company, the blockchain is mostly marketing. So after going through all of this, here's where I actually land. The technology is real. I want to be clear about that. This isn't like some of the other crypto stuff where you pull on the thread and there's nothing there. The blockchain is a genuinely clever solution to a problem that people have been trying to solve for a long time. How do you get a group of people who don't trust each other to agree on the same record with no referee in the middle? That's hard, and this solves it. For Bitcoin specifically, I think the blockchain is what makes the whole thing actually matter. Not the price, the fact that nobody controls it. There's no company that owns it, no institution that can change the rules, no government that can print more of it. The blockchain is the reason that's possible. It's the architecture underneath the claim, now, beyond Bitcoin. I'll be honest, I'm watching, not convinced. There are real applications being built on this technology. Smart contracts are interesting. Some of what's happening in decentralized finance is worth paying attention to, but there's also an enormous amount of projects using the word blockchain the same way I used to, as a thing that sounds important without being able to say why, and I think most of those projects don't survive the next few years. My friend who pulled me into Bitcoin, he's not thinking about any of this. He's watching the price. And I get it, that's where most people are. But I started this channel because I think the more interesting question isn't what the price does next week. It's whether the underlying system is actually built on something real. And on that question, for Bitcoin at least, I think the answer is yes. Next week, we're getting into the collapse of Do Kwon's Luna project, a blockchain that lost $40 billion in 72 hours. If you want to understand how that's even possible, that video's going to explain it. Next week, the Do Kwon collapse. $40 billion, 72 hours, a blockchain that was supposed to be stable and wasn't. If you want to understand what went wrong and why it can happen again, that video's for you.